Ya, Assalamualaikum and selamat sejahtera. My name is Muhaimin and Ismail. I will be presenting about my PSM2 project, which is titled Simulation of GPS-based TPI for LRT Kelana Jaya Line. First of all, I am going to start with the abstract of the project. So, Public Address and Passenger Information System (PAPIS) is significant in the railway industry as it provides multiple information to the passengers, including the train's current and next station location. The information displayed is reliant on the train's positioning information or TPI, which was gained from multiple sources such as radio frequency identification (RFID) and global positioning system (GPS). For light railway transit (LRT) Kelana Jaya Line, signaling and RFID had been used in the past as a source of TPI. However, issues arise from the use of both methods, hence the use of GPS was proposed. The objective of this project is to understand the PAPIS and GPS concept for TPI, to analyze the feasibility of the system, the concept of TPI, a brief detail of LRT Kelana Jaya Line, and the working principle of GPS-based TPI simulator for the project will be detailed in the methodology session. As a result, it is expected that GPS simulator will work as a source for TPI and is feasible for LRT Kelana Jaya Line. To conclude, a complete simulation of how the GPS broadcasts its signal, which includes coordinates of the train, will be done. Moving on to the introduction. The APIS is an important part of railway system that requires train positioning information. LRT Kelana Jaya Line used signaling and RFID in the past, but due to the issues of each method, which is signaling, when a railway line wants to expand its fleet, multiple configuration settings need to be updated each time. Next, RFID. So for RFID, replacing parts that are broken is becoming impossible because it was declared obsolete. Other than that, maintenance also is a challenge because the tag is sensitive, which means that if the tag is accidentally touched, the system will fail. Therefore, the GPS-based system is proposed. This project is based on the GPS system proposed. For the objective, the first objective is to determine the GPS coordinates of each station in LRT Kelana Jaya Line. Next, to learn the system of GPS-based simulator for train positioning information. And finally, to create a GPS simulation model using Python language for train positioning information. Moving on to literature review. The first topic of the literature review is Public Address and Passenger Information System or PAPIS. This section explores the use of PAPIS in railway industries. Moving on. Second topic is Train Positioning Information or TPI. This part explains in detail the purpose of TPI and then briefly touch the subject matter of GPS. The third topic is LRT Kelana Jaya Line. In this one, the history of LRT Kelana Jaya Line and its expansion in the project of Club 27 is shown. Finally, the use of GPS for train positioning information. As shown before, this explains further about GPS itself and its use in the railway industry, especially TPI. Moving on to the methodology part, the first step of this project is to obtain the GPS coordinates of all LRT Kelana Jaya Line stations and convert it to decimal degree format. And then put all the coordinates in a TXT file, or in other words, in a notepad. And then create a Python program which is able to retrieve the coordinates from the file path. Finally, execute the output and screenshot parts that are important for the thesis and put it in the result section. Moving on to the results. These are some excerpts of the output of the Python simulator. The first pic shows the prompt for user to pick the direction of the train. This means that the user can choose whether going to Putrahai or Gombak. 1 for Putrahai, 2 for Gombak. And the second page shows the prompt for the user to choose the starting station of the train. For example, if the user presses 1 or 2, 1 will go to Taman Melati and 2 will start from Wangsa Maju. And then the third page shows the output during the train's journey, which includes coordinates, distance, speed, next stop, and acceleration. The interval of this output, which the third bit, is every 1 second, which means that every 1 second this output will update its coordinate and distance and also the speed of the train. Finally, this output also include the train's acceleration when it starts its trip and deceleration when it approaches the next station. To detail, for example, when the train is only starting from Gombak, it will increase its acceleration to reach the next station faster, and then it will decelerate when it approaches Taman Melati. For the conclusion, to conclude this project, a complete understanding of how GPS works and how to gain the coordinates of train stations in LRT Kelana Jaya Line will be achieved. After that, the concept of how the GPS is used to broadcast its signal, which includes the coordinates of the stations to the PSC, is learned. Finally, a simulation model of the GPS-based TPI is successfully created by using Python as its programming language and taking advantage of the UDP connection. With that, I conclude this presentation. Thank you.